To be able to explain the physics of nuclear fusion, we're going to start with just a day at the arcade. So you and your friend decide to play a game of pool. And in this particular game, you're going to try striking two billiard balls with your stick at the same time so that they're able to that they're able to go inside the hole simultaneously. For this to happen, we're going to look at the entire pool board as a plasma field. So our pool board is just going to be where all of these balls are interacting. And then our stick that we're using to push these particles is going to be our gamma rays, or a series of gamma rays. This is what's a form of radiation. It's what changes the energy state, what makes it move more energetically. And then we're going to view all of the balls, and all of our billiard balls have numbers on them, as hydrogen atoms with different numbers of neutrons. So all of the numbers on the billiard balls are going to be our mass numbers, which tell us the number of protons, their positive charge, and the number of neutrons, which is mu for neutral, which is just no charge. And we're only going to focus on the balls with the numbers 2 and 3. 2 we can also just call deuterium, and then 3 we can call tritium. When we're able to try making these balls collide, they first just bounce off each other because they're both positively charged, and that means that they're going to repel each other. To be able to overcome this, we basically have to use a lot more force. Think about like how many times you're gonna have to really push with your stick to be able to make sure that that they manage to go together. And at the same time, we also can increase the number of particles, and then we can also increase just the velocity that all of these are traveling, so that we can maximize our chances of fusion. This usually only happens at around 200 million degrees Celsius, which is something that's only possible on the sun and on the stars. So, when we finally manage to get this to happen, one additional neutron is released after the formation of an alpha particle, which, remember, forms helium because we have two protons now, and we have two neutrons. And then we have that additional neutron, which releases a lot of energy when we have billions and billions of reactions going on. So today, or at least recently, we've been able to build a tokamak, which is able to confine this energy. Although we're not able to, or we haven't been able to create more energy than we put in yet, it's definitely not impossible and something that we could hope for.